Okay, so I think next up is Laura from D2.
Yes, I'm here.
Oh, cool. Laura, I think Laura is going to speak to us a bit about mobility patterns and their development over time. So take it away, Laura.
Yes. Good afternoon or good morning, everyone. Can you see my slides? Can you hear me and see my slides?
Yes, we can.
Oh, okay, perfect. Yes, so I'm going to present sort of like our journey throughout 2020 and 2021 when we've been monitoring changes in mobility patterns in Denmark as part of the HOPE project. I'm assistant professor at the Technical University of Denmark, and I'm also affiliated to Denmark Statistics in the context of this study. We've been monitoring changes in mobility behavior together with the team, DTU, and the Copenhagen Center for Social Data Science, with Sune Lehmann, Pete Molgaard, Ulf Aslak, and Jonas Juhl from last year. So we kind of like started by looking at data that was collected by Facebook, and we put together a platform at the beginning of last year that you can still find online at covid19.compute.dtu.dk, where we kind of like visualize data. As you can see here is like a small snapshot of what you can find on the website. And yeah, at the beginning we were really just working with Facebook, data collected by Facebook in the framework of the Data for Social Good program. And then we started analyzing data that was collected by mobile phone companies. And as you can see here, there's also some visualizations on the website that basically show this data. This is a data set that you will be able to look at during the Datathon. We put it together by combining data from 4 different mobile operators in Denmark. It was a pretty challenging pre-processing task because each mobile phone company aggregates data internally in different ways. So when we combine them together, and we do so to make sure that no information about individual companies is made public, we need to make some approximation and assumption. And those of you who will work with this data will see that. So what does the data show? So the data is basically showing the number of trips between Danish municipalities over time. So in a way, it provides like a much more coarse-grained description than the one that Nika was talking about when we look at like direct social contacts, because here we look at data at the level of the commune, basically. But the 4 companies have a very large share of Danish customers, so it's about 83% of Danish people. And it has the resolution of the municipalities, and we look at data at the level of the single day. And we also looked at data collected by Facebook in the framework of the Data for Good program, which you will also be able to access via the website, where we also can compare basically what happened in Denmark versus what happened in other European and non-European countries throughout last year. So yeah, here I will kind of briefly guide you through, of course, some of the more general results or observations we could draw throughout the year, and then a more specific study that we run with the team. So, of course, following the first Danish lockdown, we observed this like decrease in total number of trips in Denmark. And then, of course, the sort of overall number of trips in Denmark was closely following the introduction of different non-pharmaceutical interventions. So total number of trips, of course, increased when there was a reopening. And then with the second lockdown, we can definitely see at the level of the entire country that the trips reduced again. And then when the vaccination campaign was unfolded and the reopening started again, now behavior is sort of back to normal. When we look in terms of like relative changes, becomes even more clear that basically these were the trends throughout the year, and they were not sort of, but changes did not apply in the same way in all the regions. So in the capital region of Denmark, people reduced travel behavior much more compared to the baseline with respect to other Danish regions. As you can see in the bottom figure, for example, like in northern Jutland, trips reduced less over time. Now behavior is back to normal. We should always say that the baseline we consider is like January 2000 or February 2020. So of course we cannot really compare like summer behavior with winter behavior, but still we can clearly see that now we are definitely like above the baseline in terms of total number of trips in Denmark. So with the data that we have, we can basically build like a network across Denmark that describes the number of trips between any pair of locations. And what you can see here on the left-hand side is like how the network looked like in early February 2020. And then in the plots on the right, you can see sort of like the relative change in terms of number of trips for each link on the map. And we see like the map is mostly red, meaning like most links, for most pairs of city, number of trips reduced. But then there's some places mostly connecting like islands and like holiday destination where the number of trips actually increased during the first lockdown. So this is kind of like puzzling us. And we basically like started thinking about, okay, mobility is many different things, like the total number of trips reduced during the lockdowns, but mobility is not, it comes down to commuting, leisure trips, vacations, so it's many different things. And we were interested in trying to understand what were changes in mobility with respect to these different types of behavior. And because we don't have access to like detailed fine-grained information, we had to sort of find a solution to investigate different mobility behavior. So we used a method called negative matrix factorization to kind of identify components in travel behavior. And what this boils down is basically decomposing like a matrix describing the number of trips over time into the product of two different matrices. And I'm happy to answer questions about sort of like details later on. And the idea is that we find like three main mobility components that describe mobility patterns in Denmark over time. So we have the original time series describing the total number of trips, but we can decompose it into 3 time series. And what we discover is that basically this 3 time series corresponds roughly to commuting behavior, so the green line, to sort of like weekend travel, so the orange line, and to holiday travel, so the blue line. So we basically, thanks to this technique, we basically managed to figure out and decompose the network in these 3 main components. And what we observe is that actually during lockdown, so during like the red period, while the overall mobility patterns reduced and commuting behavior reduced, we have that weekend travel was actually increasing with respect to the previous periods. So during lockdown, the weekend component increased by 69%. So the idea is that people behavior during lockdowns was like much more similar to their weekend travel behavior than on average. And in fact, we observed that this observation is kind of similar also in other countries where we used data from Facebook. So in fact, now that we have these like 3 different travel components, we use those to build basically 3 different networks describing holiday patterns, weekend patterns, and workday patterns. And we are interested in studying how these networks evolved over time. In particular, we were looking at what's called the effective distance between locations. So the effective distance, when you think about a pandemic, is basically a type of distance between 2 locations that is not based on geographical distance, but it's based on like how many people travel from one location to the other. And this is the distance that matters when it comes to the virus, right? Because the virus will travel much faster between 2 locations if there's many travelers between the 2. So it basically counts the fraction of travelers that go from a given location to any other locations among all travelers. And it's been found in previous studies that this effective distance correlate with the arrival time of a disease. So, of course, the more travelers, and the faster the disease will arrive elsewhere. So the idea is that we can compute this effective distance for these different networks that we have. So the one describing weekend patterns, holiday patterns, and workday patterns. And we looked at like changes in the network structure. What we found is that basically when we remove the holiday component, the effective distance does not really change throughout time. So here what you see is the distribution of effective distance among pairs of locations in Denmark over time. So time is basically the y-axis. And what you see is the distribution is really similar over time, meaning that when we remove the holiday component, the network structure has remained the same. Instead, when we remove the weekend component, the network structure does change, and so does when we remove the workday component. So the idea here is that what we discovered is that there was an overall reduction of trips in Denmark, but the network structure did not change if we would consider only weekend and workday patterns. So the network structure has changed throughout 2020 and 2021 due to changes in the holiday component. So in how we moved for sort of like during to reach holiday destinations and so on. So this is the sort of like a summary of this specific study. Of course, there's like many more insights that can be drawn by looking at the mobility data set, and I hope many of you will look at it and gives us even more insights. But with respect to this study, what we found is that we can decompose mobility patterns into components using factorization techniques. And this component roughly correspond to workdays, weekends, and holiday mobility. This is not granted, right? Because the data we have is very coarse-grained. So it's really not easy to extract these components from aggregated data. And what we found is that during lockdown, mobility flows were more similar to weekend mobility flows. And the network structure changed during lockdown due to changes in sort of holiday types of mobility. Yes, this study is accepted in Physical Transaction A, but is not published yet. You can find other studies from my group in this slide, and I really invite you to look at the website where basically you can explore the data yourself. We have this interactive platform that we set up last year that you can explore yourself. Now the data stream has been interrupted, so it's not updated regularly anymore, but it was updated until last July. So you can really explore yourself changes in mobility throughout the pandemic. Yes, this is all from me. I look very much forward to questions.
Thank you very much for this most interesting talk. There should be questions, because we all are Facebook users, I guess. There's a question over there.
Oh, thank you for the talk. If you showed in slide 3 these 3 different distributions of the components, and you say that there's a difference between the first one and the second one. I had a very hard time seeing that, so maybe you can give a few more words on that, why you see that there's a difference between the two.
Wait, let me try to go back to the slide. I lost it. Here we go. Are you talking about this slide?
No, the second to last slide. Yeah.
Yes. Yes. So basically, you can see that the shape of the distribution in this second and third plot kind of like evolves in time. This can be tested statistically, that the shape of the distribution changes. So the average of the distribution doesn't change because this effective distance is a measure that basically doesn't account for changes in overall number of trips. So the average will always be roughly the same, but the shape and the width of these distributions change. And instead, statistically speaking, in the first case, the distribution is more stable over time. So we don't have drastic changes in the effective distance between pairs of location over time. Does it answer?
Yeah. So the second group, does that change correspond to the number of cases?
We haven't really tested this, but definitely the change does reflect. So it is more pronounced in periods of lockdown. So somehow when there were restrictions, this was reflected in changes in the network structure, but we haven't, I have to say, directly tested if there's a relation between the number of cases and this evolution of effective distance for the three components.